Here's the problem MCP solves in one sentence. Before it, every AI app had to build its own custom connection to every single tool. 10 apps and 10 tools meant 100 separate integrations to build and maintain. MCP turns that 100 into 20. Build a tool once and every AI app can use it. That's the whole idea. Now let's unpack how it actually works. Picture this: you've built an AI assistant and you want it to do real work. Read a file from your computer, pull a record from your database, send a message in Slack, check an issue in GitHub. Every one of those is a separate system with its own API, its own login, its own rules. For most of 2023 and 2024, you had to hand code every one of those connections yourself. And here's the painful part. The next developer building a different AI app had to do the exact same work all over again from scratch. Engineers have a name for this: the N by M problem. N different AI apps, each needing custom code for M different tools. 10 apps connecting to 10 tools is 100 integrations, everyone built by hand, everyone maintained separately. Nothing shared, every connection reinventing its own security and its own data handling. That is the mess MCP was created to clean up. So here's the fix. MCP, the Model Context Protocol, is an open standard announced by Anthropic on November 25, 2024. The idea is simple but powerful. Instead of every app building its own private connection to every tool, everyone agrees on one shared language. Build a connector once following that standard, and any AI app that speaks MCP can use it immediately. That 100 integration problem collapses down to 20, 10 apps plus 10 tools, N plus M instead of N by M. MCP is now maintained under the Linux Foundation as part of its Agentic AI Foundation, so it isn't owned by any single company. The easiest way to picture it: it's a universal adapter between AI models and the outside world. What USB did for hardware, MCP is doing for AI tools. Let's look under the hood. The architecture has 3 parts and they are easy to mix up, so let's be precise. First, the host, that's the AI application you actually use. Claude Desktop, a code editor, a chat app. The host is where the model lives. Second, the client. The client lives inside the host and its job is to manage one single connection to one server. If the host connects to 5 servers, it runs 5 clients. Third, the server. The server is a separate program that exposes tools and data. It might run on your own machine or it might live on a remote service. So the chain is: host contains client, client connects to server. And how do they talk? Through a messaging format called JSON-RPC 2.0. It's just a structured way of sending a request and getting a response back. You don't need to memorize it, but you'll see the name everywhere in MCP. Let's make this concrete by tracing one actual request, start to finish. Say you ask your assistant, "What's in my project's README file?" Step 1, the model realizes it needs a tool, so the client asks the server to list what tools are available. Step 2, the server replies, "Here's a tool called read file and here's exactly what it needs to run." Step 3, the model decides to use it, and this part matters. The host pauses and asks you for permission first. Step 4, you approve. The client calls the tool, the server reads the file and hands the contents back. Step 5, the model takes that content and writes you a plain answer. That whole loop: discover, request, approve, execute, respond. That is the beating heart of MCP. Every interaction is some version of it. Now that server can offer 3 kinds of things, and understanding these 3 is the single most important part of this episode. Number 1, tools. Tools are actions, things the model can do. Search the web, send an email, run a query, create a file. If it changes something or performs a task, it's a tool. Number 2, resources. Resources are read-only context, each identified by a URI, a file, a database record, a document. The model reads them for information. Reading a resource doesn't do anything, it just supplies knowledge. Number 3, prompts. Prompts are reusable templates the server provides, pre-written instructions that help the model handle a specific task the right way. Here's the trap almost everyone falls into: confusing tools and resources. So burn this in: a tool takes an action, a resource gives information. Action versus information. Get that one distinction right, and 90% of MCP suddenly makes sense. Now, it isn't a one-way street. The client can offer capabilities back to the server too. There are 3 of these, they're newer and most tutorials skip them. First, sampling. This lets a server ask the host to run the model on its behalf. If a server needs the AI to summarize something mid-task, it can request that, with your host staying in control the whole time. Second, routes. This is how the client tells the server where it is allowed to operate. For example, you may work inside this one folder and nowhere else. It's a safety boundary. Third, elicitation. This lets a server pause and ask you for more information during a task. If it needs a confirmation or a missing detail, it can request it right then instead of just failing. So, tools, resources, and prompts on the server side, sampling, routes, and elicitation on the client side. 6 primitives total. That's the entire vocabulary of MCP. So how do a client and server physically connect? 2 standard ways. The first is standard I/O, used when the server runs locally right on your own machine. It's the default and it's the simplest. The second is Streamable HTTP, used when the server lives on a remote service across the network. You might see an older method mentioned called HTTP plus SSE. It was the early approach for remote servers, but it's now deprecated, so don't build anything new on it. And before any real work happens, the 2 sides run a handshake called initialization. The client says hello and lists what it can do. The server says hello back and lists its tools, resources, and prompts. They agree on a shared version, and only then does the conversation begin. That handshake is why any compliant client can talk to any compliant server with no special casing. Now we have to talk about the part people love to ignore: security. Think about what MCP actually enables. You're letting a model read your files, reach your databases, and take actions on your behalf. That's powerful, and it's also risky. So the protocol builds in guardrails. For remote servers, MCP uses OAuth 2.1, the same kind of secure sign-in flow you already trust elsewhere, protected by TLS encryption. But the most important guardrail is you. A well-behaved host asks for your explicit consent before it runs a tool. The human stays in the loop. And you should still be careful. A malicious or sloppy server is a genuine risk. So only connect servers you trust, the same way you'd only install software you trust. The recent spec revisions have spent most of their effort right here, hardening authorization. Because in the real world, this is where the danger lives. Enough theory, how do you actually use this today? The very first MCP client was Claude Desktop, and it's still the easiest place to start. You add a server in its settings, and suddenly your assistant can reach that tool. From there, support has spread almost everywhere. Claude Code, Cursor, VS Code, and many more all speak MCP now. And you don't have to build servers from scratch. There are already thousands of ready-made ones, for GitHub, for databases, for file systems, for Slack, and countless other services. You install a server, point your client at it, approve the connection, and your AI can now do something it never could before. That's the payoff, and it takes minutes, not weeks. So why did this explode the way it did? By the middle of 2026, there were nearly 16,000 public MCP servers on GitHub. The official software kits, the SDKs, crossed 1 billion downloads. And critically, the biggest names in AI all adopted it: Anthropic, OpenAI, Google, Microsoft, GitHub, and more. That last point is the real story. Rival companies almost never agree on a standard. When they do, it means the problem was universal and the solution was good enough that fighting it made no sense. That's how MCP went from one company's idea to the default plumbing of the AI world in barely a year. And it's still evolving fast. The July 28, 2026 specification was the biggest change since launch. It made the protocol's core stateless, which lets servers scale on ordinary web infrastructure, and it introduced new capabilities like MCP apps. But that's the frontier, and it's exactly where we'll pick up in the next episode. For now, let's lock in what you've got. MCP solves the N by M problem. It's a universal adapter built on a host, a client, and a server. The server offers tools, resources, and prompts. The client offers sampling, routes, and elicitation, and a human stays in control the whole way. Master those, and every single thing in the agentic AI world gets easier to understand, because almost all of it is built on top of this. If this made MCP finally click for you, subscribe. The next episode goes a level deeper. See you there.